So thank you for being here. I'm excited and grateful and proud to be back at Mage Titans. So thanks John and the whole team for inviting me back, and thanks all of you for being here again. And also, here we go, that's better. Thanks Alistair for this brilliant talk, and James. I was sitting up there listening, and you were like, oh, he's taking the words out of my mouth. Right? It's like, oh, awesome. That's so good, because a lot of what I will be trying to say really builds on top of what Alistair said, like how can we decouple code from the framework, and how can we build small pieces of code, small units that we can compose together and do their job well. So that's what I want to talk about. And first, a confession. When I started thinking about what I want to talk about for the new Mage Titans conference, I felt, well, yeah, I want to talk about something that inspires me and that excites me and that I'm thinking about a lot, right? Because preparing a presentation helps me to focus my thoughts in a way. And then I wrote the synopsis and sent it off, everybody's happy, and then I realized it has nothing to do with Magento. It's like, oh, okay, first. So I'm a little bit nervous here. But on the other hand, of course, it's about development, so it has everything to do with Magento for us developers, right? So it's all good. So the title I chose, Architecture in the Small, is about, for one, somehow the term architecture and software for me doesn't really fit. My father's an architect and I don't do what he does, right? Not at all, not even close. But what writing code for me is making a ton of small decisions, every line of code, right? And each of those decisions somehow influences the piece of software, the artifact that I'm creating as my work. And it influences how I can continue using it later on and continue building on top of it. So for me as a developer, I want to do my job well. Right? And I assume that's why you're here too, right? You want to do your job too. When I started writing PHP a long time ago, I really just, copy and paste, didn't really care. As long as it seemed to work, I was happy. So that wasn't a very responsible way of writing code. Later, a couple of years later, I spent most of my time writing Typo 3 plugins, which was, at least I tried them to make in a way that they're kind of reusable for the agencies and solution integrators I was working for at the time. So that already was a lot more responsible in a way. Then starting out as a Magento developer, well, at first I just was happy to get it to work, to be honest, right? It just was like, yeah, I didn't really get the big picture of it. It took me a long time to finally understand most of it. And yeah, so getting it to work was priority one. Later that moved into trying to get it to work fast or work well or work between upgrades. So that's kind of to summarize the evolution that I want to show here is basically I'm trying to build software in a way that it's better. And better means I'm focusing less on it just has to work, but instead that's not good enough anymore. I want to write code that does its job well and that other people enjoy working with too. And I fail, more or less, right? So sometimes more, sometimes less, but at least that's what I aim for. And the last 2 years or so, I've been looking especially beyond Magento and beyond the direct area that I'm working in. What can I learn from other people? How are they writing code? How do people at Google write code, and at Apple, and at all these other companies? And what can I take from there to help me produce better code? And so these are some of the things that I tried to pull out of that looking around for my work with Magento and with PHP, and that I found useful. And I'm just trying to share that, so hopefully you might find them too, and you might enjoy playing with them, and yeah, hopefully it'll help us build more smaller encapsulated pieces of code that do one job well. Good. So these are some of the people I admire a lot. They're like I aspire to be a little bit like them. They're really awesome. My current favorite is Rich Hickey, author of Closure, and he's a great speaker. Watch all his talks on YouTube. And anyway, so all these people are great. They've got a great sense of humor too. And go ahead and dig them up. Look them up. Brilliant people, lots to learn. And even though I got inspired a lot by them, right? I'm not just trying to reproduce what they say here. So these thoughts are kind of my own, but heavily influenced by what I read and heard them say. But it's totally possible that I came to wrong conclusions. Right? So take it with a grain of salt here. Anything I say, I might change my mind about it tomorrow. Right? So next year, if I say something completely different, I reserve that freedom for me. And if I get something wrong, that's my fault. Right? It has nothing to do with these other guys. All right, so these are the topics I want to talk about. And they're kind of related to each other. So I want to talk about extraction and encapsulation, managing state, validity, immutability, and idempotence. If there's time, we'll see about that. So all these tools help me, are tools that I try to use to produce better code. So I want to start with extraction and encapsulation. So what is extraction in terms of software development? Right. So I kind of had a pretty nebulous idea what is extraction, and it turns out that it's actually pretty clearly defined, and it's a subset of refactoring, which is another of those buzzwords, right? Extraction, refactoring. Now I have plenty of those words. I like that kind of words, so please forgive me if I sprinkle them through my slides. I try to explain them whenever one comes up. So refactoring can mean several things, can be a noun, can be a verb, but this kind of captures this nicely for me. So refactoring is a process of changing a software system and changing it in such a way that we modify the internal structure, but not the external behavior. And the purpose of doing refactoring is to improve the internal structure, so it's maybe quicker, maybe more maintainable, maybe easier to understand, maybe easier to modify in future. And extraction is a subset of that. And many different kinds of extractions are collected in this book together with many other different refactorings that are available. The book was released in 1999. Now it's in its 26th edition. So a book that's around that long definitely deserves some attention. And yeah, I would recommend checking it out. It's Java-based, but it doesn't matter. It all applies just the same to PHP. So the usual purpose of refactoring is to get rid of smelly code. So if there's something we don't like about the code duplication, plenty of other code smells, we can use refactoring to get rid of that code smell. But in case of extraction, I found it to be more than just that. So instead of seeing a code smell and then applying maybe extraction to get rid of it, I find extraction can be a tool to simplify my code. And basically, it increases the amount of code, but each unit of the code is a lot simpler. And the nice thing about simplicity is it makes things visible that were previously hidden. So some code smell that might have been in the code all along, but I didn't see it. Just looking over the code, everything looked okay, and then I start taking things apart into smaller units, and suddenly I realize, wait a moment, something isn't quite right there. And I tried to find an example, and that's straight out of the Magento 2 code base. That's from the method from the product model. And to be honest, I'm not 100% sure what it does. That's not even important, right? So this is in there, at least a couple of, it's developed branch, I don't know, a couple of weeks old. So what can we learn just by looking at this method here? So it takes an array and it converts to media gallery interface. Okay, it accumulates some records in an entries array, iterates over this array, and then gets a converter pool and converts it somehow. Okay, so that's all I can see here. Now, just looking for a good example, there were others, but this one kind of also fit nicely on a slide. I decided, okay, well, the first extraction that's kind of a classical one was I'll remove the loop content into its own method, just to make it more concise. So now the first method is still the same. I just took everything inside of it and moved it into its own method. So here now we can see convert image to media gallery entry, okay. Now this actually reads a little bit nicer, right? I'm not concerned any longer how it does its job, but just see what it does. So giving it a nice method name helps. And then the method convert image to media gallery entry, what does this do? Okay, it gets the media converter from the media gallery entry converter pool by some kind of media type that's part of the image array. It seems to have that record in there. And then it calls convert to. And then looking at this code, I realized, wait a moment. This method has nothing to do with the product. It just gets passed along as an argument, right? But it doesn't use any properties of the product. It doesn't call any methods of the image of the product. So where does it actually belong? In fact, it's even calling methods on a return value from a different object. So it violates the law of Demeter. So where does this belong? And well, actually, we could take this method just as it is and put it into the media gallery entry converter pool. So that would be the better place. Right? And that, I didn't realize that at first. Just by extracting it made that visible. So moving that into the converter pool, now it takes the image and the product. And here we can see, okay, now all the internal structure of the image array, that's only the converter deals with that. The product has no knowledge of it and doesn't need to, right? And now we can call that converter pool method directly in the array. So that's kind of like extracting parts, realizing, oh, wait a moment, this doesn't belong here. It's more easy to reuse. That's just a simple example, right? But it's a powerful technique. And actually, the simpler the technique, probably the more useful and powerful it is. So I've been using that a lot and having good results there. And what it boils down to, extraction allows us to encapsulate the functionality in the right place, in the right way. So encapsulation, looked up the definition because that's how kind of the cool kids like Alistair and Rich Hickey and others build presentation now, right? In general, encapsulation is the inclusion of one thing within another thing so that the included thing is not apparent. Or for objects, that means we can use an object that uses another object and it doesn't care about how the other object does its thing. It just calls a method and that's encapsulated within the other object. So kind of like what the refactoring did. And as soon as we move all the code to the right place, encapsulate it in the right way, we end up with classes that have nice clear boundaries, are easy to test, have a nice interface that can be exposed, can be composed together with other classes, and we end up with a more maintainable and better system. So that boils down to the tell, don't ask principle. So extraction enables us to properly encapsulate functionality. So I want to propose that it's good to write code that is easy and simple to extract. Because that's kind of the premise for the rest of the other topics. Because the other topics help me write code that's easy to extract. Or simple to extract, let's put it that way. So the first thing I want to talk about are immutable objects and how they can help us to manage state. That's actually probably the largest part of the presentation here. So first, once again, immutable. What does it even mean? Well, in object-oriented and functional programming, it means that an object, once it has been created, cannot be modified. That's at least what Wikipedia has to say about it. Yeah, when I heard about it at first, I was like, yeah, but why? Why would I want to do such a thing? Right? I mean, I've got objects, they've got properties, I can just assign new values. It sounds kind of like I'm cutting off my own leg so I can't walk anymore. And so why would I want to make an object immutable? And there's recently been a PSR 7 released by the FIG group about an HTTP client, and it's all about an immutable class interface, and a lot of people were flaming it, and I wrote a lot of statements like, oh, immutable, they're immutable, and that helps, supposedly helps to avoid a whole class of bugs, but they never said what are those bugs that immutability helps to avoid. So what are they? Well, let's have a look. So first of all, I think immutability really increases the reasonability about code. It reduces the complexity I have to manage in my brain. So looking at the code, it's much easier for me to understand what's actually happening because I don't have to worry about any kind of state change, right? That just takes out a whole dimension. And if I understand what I'm seeing, I know if that code is actually correct or if it's not correct. Right? So it's much easier to see what I'm dealing with. Because when objects are changed somewhere in distant code, it becomes a lot more tricky to track what changed, when it changed, and how it changed. Right? Suddenly, it becomes all this web of things instead of a nice, clear interface. So that's one of the benefits. Just general, it's easier to think about them. The main class of bugs, however, that immutable objects avoid are bugs that revolve around the topic of temporal coupling. So what is temporal coupling? Here is a nice example, also from the Magento 2 code base. It's out of the Braintree module in the method partial capture. there were other examples too, and I'm not intending, just to pick out Magento here to get some kind of bad examples, just because I somehow wanted to make this talk about Magento too, right? So that's why I picked my examples from there. It could have been anything. So what happens here? One line of code. This config init environment with a store ID. And it's in the method partial capture. Okay, knowing Magento 1, I've got a rough idea what it's about. So what's the problem with this line of code? Well, first of all, what state was the config on before it's initialized? What is the current store? Or does it has to be initialized before it can be used? Or is the admin scope, right? It's pretty much undefined. So we have to call this method first, I guess. But what would happen if we initialize it twice with different stores IDs? Is that a bug? Are we allowed to do that? Right. Would that invalidate other methods that were called earlier? So what happens if a different method behind that was called after partial capture on the payment object is called that relies on the config being initialized? And then somebody changes the code and calls them in the wrong order. Would that work? Maybe, right? But those are the kind of problems we don't know. We would have to look at the whole code. We have to figure out all the code that uses that to know what's actually happening here. What happens if somebody else builds their own payment module, takes this as an example, and then somehow forgets to call init environment? Extracting code out of methods like that is really difficult, because if, let's say I take some code that comes after init environment and I move it into a different method so it can be easily reused. Now I'm basically breaking the relationship between, okay, the environment has to be initialized before this piece of code, so I can't extract it. Or I will, it basically doesn't allow for reuse anymore. So this kind of temporal coupling makes it really difficult to extract code. And last of all, of course, what happens if another object has a reference to the same config instance? I don't know if it's a shared instance or not. So what happens if the config scope is changed and the other class doesn't realize it's changed or doesn't expect the change, right? So those are all these issues that revolve around this kind of temporal coupling. Goes on and on. So this kind of temporal coupling is a form of complexity that's added as soon as there's some kind of initialization method that can be called from the outside, or actually some kind of setter, any method that changes an object state that can be called from outside of the object itself. Right? And that's at the core of why immutable objects are simpler. Now, it's good to distinguish between external and internal immutability here. So external immutability means I have a method that has setters or an init method like we saw, and that changes the object state. Now that, of course, introduces all the problems that I just talked about. Internal immutability means I have a class with some state, and I have no method that can be called from the external, from outside of the class to change the state, but it's there are certain methods that change the state internally. Right? So as soon as there is some kind of state change, I add complexity. It doesn't matter if it's internal or external. But it's good to distinguish between the two different types, because internal mutability allows for memoization. Right? And that's actually a term that Daniel introduced me to last year. All of you, I wasn't familiar with it before. It's basically in-memory caching. Right? So just another word I like. It's always cool to know those. A lot of languages have support built in for memoization. You just add an annotation, like hacklang, for example. Many other Lisps and other methods, languages too. But PHP has not, but we can build our own, right? So we call a method and do some expensive calculation. And if the same method is called with the same arguments later on, we just return the same result. That's what it boils down to. And that's only possible with internal mutability. Right, doesn't mean we have to have external mutability here. Because as soon as we have external mutability, what would need to happen is we would have to reset all those memoized values. Clear the cache again. And that's complexity. It's not difficult, but it's easy to miss or do wrong. Caching is hard. Caching is really hard. Right, so that's part of it. So anyway, memoization is a lot simpler to do with immutable objects, since it can't be invalidated. testing immutable objects is incredibly simple, using them inside of code that uses immutable objects. As soon as you have some kind of objects that are mutable, we end up with really icky test doubles. So something like this, where we have to track if a method was called or not using closure, and then it's a mess. Don't go there. So what most people do, instead they simply assume the test double is initialized in a certain state. But of course, then it's easy to miss calling the matching setters or initialization methods in the code that's currently being tested. So having an immutable object takes that whole worry away. The object simply is what it is. Can't be changed. Very easy to do. In fact, if you have an immutable object, in many cases you don't even need a test double. You can use a real thing. Okay, objects are simpler to cache if they're immutable. One example where I encountered that a couple of years ago was in the Enterprise Edition full-page cache, where the Enterprise Edition full-page cache, Magento 1 now, is written to the cache in the controller front send response before event. Right? Now, I don't exactly remember what it was, but there are plenty of events that are fired later after the response is written to the cache. And if an observer changes the response during any of those other events, or in an observer that's fired later for the same event, the first time, while the response is being generated for the first time, that change is applied. But later, it doesn't matter if it's a header that was added or the content was modified somehow, it's gone. It isn't part of the cached response. And that kind of problem could be avoided if the response were immutable. Then at least it would be clear that it's not possible to change the response in that point in time, and it would force us to look for the right extension point to apply the change. Right? So it makes code easier to use if we can't just start messing around somewhere in the objects, right? And just assume it works, because then it gets a lot trickier to have everything work correctly together. Another point, once valid, always valid. It's impossible for an immutable object, if it was created in a valid state, to become invalid. Here's an example from Magento 1 again. Let's assume we have a product straight out of a product collection, which included some pricing data. It includes a price and a special price. So far, so good. Now let's assume we're setting a price and a special price. The price that's actually displayed on the page would still be the original special price. Right? So by setting these values, we created a product in an invalid state, technically. And once again, that's not possible using immutable objects. So how do the actual values get into the immutable object? Well, constructor injection, first of all, plain and simple. That's also what Magento 2 uses most of the time, even though they abandoned the idea of making most objects immutable at some point. So here's an example, this time not from Magento 2 or Magento. It's pretty simple, right? We create the new instance and pass in everything it needs, all data. And once it's created, it can't be changed anymore. We're not limited to just using the regular constructor though, right? So depending on how we want to construct the class, we can add additional constructors, so-called named constructors, that are basically static factory methods. For an HTTP request, it might be something like this, from global state. And global state always is kind of messy, so it's nice to indicate that we're doing messy stuff in the method name. It might look something like this. So we get all the values from the super global environment, and then maybe call another factory method from scalars, which then in turn builds the arguments and calls the actual constructor. Right? So we can have different ways of constructing an object using this kind of value injection. It can be quite flexible. And these named constructors it's a way, in Java it would use polymorphic dispatch, right? You'd call a different method depending on the type of the arguments, even though the methods call the same every time. That's not possible in PHP, so instead we can use these named constructors, which also add a lot of documentary value. So I think that's actually quite a good thing. Right, so the one thing that's tricky, all these benefits, great. But the one thing that's really tricky is, in real life, things change, right? So what do I do? How do I model that with an immutable object? So the way that's done is by creating a new instance of the same object with the changed data. in PHP 5.5, the datetime immutable class was introduced. So when we create an instance, by default, it's for the current date and time, like so. And we can create a time interval and add that, today add 24 hours, but that doesn't change the instance of today. Instead, it returns a new instance of datetime immutable. Today still is the same date. Tomorrow contains the added interval. This is how this kind of change over time is modeled in immutable objects. So it's a little strange. So let's think about when might it not be a good idea to use mutability, right? And for me, that boils down to, does the immutability make my code more simple or does it make it more complex? I want simple code. It's so easy to create something complex that I can't understand anymore. It happens all the time to me, right? So I try to keep things as simple as I can. And, well, let's take an example like a conference room, like this room here. You might have a location, Manchester, the event, Mage Titans, all of us are the attendees. And what happens if somebody now enters the room? Is it a new room? Of course not, right? It's still the same room, just different number of people in there. So an implementation of that would look something like this, right? We have the room, add a new person, and all that changes is the number of people. So that's a mutable object. It's very easy to understand, very easy to see and work with. But this would be the whole thing in an immutable way, right? So add person would return an updated room, which now has a different number of people inside of it. It's not really like the real world, to be honest. It's kind of weird. So the way to understand that is that each instance represents the object at a certain point in time. Right? And then we have a lot of different instances, and it's still the same entity we're modeling, right? But it's just a picture, like a snapshot of that thing at a given time. Now, the nice thing about that is it keeps history intact. So depending on what we want to do, that could be persisted in some way. We could have temporal queries to know, okay, at that point in time, the room had this many people, or this event was going on. That can be very valuable data, and that's a whole topic in itself. But it's, in a way, for me, using object-oriented development, it's not a natural way to think about things, right? It's really strange. So it adds complexity there. It's a really unaccustomed way for me to think about how to work with a model. And that can be good or bad, depending on if you like thinking about new things or not. So the bottom line for me regarding immutable objects is it really depends. If I'm building something simple, like let's say a CRUD system, it might not be necessary to do that, right? So I'll just won't. But if I don't have to worry about changes over time at all, yeah, it makes the code simpler. And then, so it depends, right? Do you have to evaluate if the costs of the added complexity of modeling change over time using immutable objects is worth the additional effort. All right. So actually, I have no idea how I'm doing on time because this slide deck doesn't show me time. DeckSet, I'm using DeckSet for the first time. But we're over anyway. Sorry? 5 to 10 minutes? Okay, thank you. All right. Crank it up a bit. So value of validity. Sorry about that. All right. So the nice thing about immutable object is that we can validate them at instantiation, and after that they'll always be valid. We can validate them in the constructor or in the name constructor. Or if the validation is particularly expensive and can be reused partially, we can also do it in a builder or factory. The constructor validation itself, of course, is the safest place to put it, because that way the object will always be valid. Right? Here's a simple example where we pass an amount into constructor. If it's not an integer, an exception is thrown. So now it's impossible to create this class, whatever it is, with a non-integer amount. So that's simple validation, and it's very valuable. But of course, that's quite simple. In real work, usually, or oftentimes, not usually, but oftentimes things are a bit more complex. And in that case, instead of adding more and more validation to one class, I find it's once again time to extract. So instead of having one class with a lot of data, it's better to extract each little part of data in its own subclasses. So here, for example, this is a product attribute list builder for whatever reasons, and it receives an array in a factory method. So it then creates a lot of little sub-objects, each one validating its sub-entry, which in turn could create other sub-objects, right? So we are building this whole graph, this tree of objects, and that then finally is used for the construction, which then only validates everything, you know, can I use these attributes in this list? So that's how you can easily delegate from one object, delegate the validation into each little sub-object. So the idea here is that each thing is a class, and each class, each object is responsible for validating its own data. And then we can compose these little objects and rest assured that whatever we do, it'll always be valid. We don't have to deal with invalid states. And that makes coding a lot more faster and better. The idea behind this are actually value objects, and there's a nice slide deck that Tim Beshashvili made about it. You can check that out. It's a nice introduction to the builder, pattern, and value object. If you haven't heard about them anywhere before, I don't want to go deeper into the idea of value objects right now. Valuable concept of value objects, right? So, but this kind of code using value object also has a cost associated with it, because if each little idea is its own class, we end up with this huge amount of classes, right? It just explodes. Suddenly we don't have 5 classes, but we have 100 happen, right? So that's expensive. There's lots of code to write and test and maintain. So what about good old scalar values, right? We have strings, integers, booleans, and arrays of these things. They're actually pretty good because, well, why not use those? The code smell name for this kind of just using scalars for everything is called primitives obsession. The idea is here to use a string or an integer or just one of those scalars to represent a domain idea. So let's say we have this concept of a customer, and we represent the age of the customer using an integer value instead of using an age class that just contains an integer. So what's bad about these? What's the problem with these primitives? Well, first of all, at least until PHP 7, we don't have type safety, but tests can help to work through that. It's very easy to end up with code duplication, because suddenly we might have the same calculation regarding age done in multiple places where it's needed, because we cannot put that method into the age if it's just an int, right? That's one of the benefits of having these value objects, that we can add behavior to the data. So that's something to watch out for. Magic values are a problem. Like if you just see some numbers or boolean somewhere, it's very difficult to understand what's actually going on. So having classes instead makes things a lot clearer. And of course we have no built-in validation. A string is a string, it's always valid as long as it's a string. So we can't add this kind of validation to them. And here again, tests help to some degree. But scalars also have a number of benefits, right? First of all, they're immutable. If you have a string, it's immutable. If you change it, it's a new string. It's not the same string anymore. So all the benefits of immutability apply to scalars. Then they're incredibly easy to create. I don't have to worry about requiring classes and auto-loading and injecting dependencies. No, it's just a pair of quotes. I've got a string. I'll just write a number, it's right there. That's incredibly easy. It can't get much more easy. Another benefit is they're easily comparable. It's very simple. I can use the built-in larger than, less than, equals operators, and it just works. As soon as I have value object, I have to add methods like is equal to, or is larger than, or is contained within. I can't use the normal PHP methods. Scalars are serializable, right? I can just send them over the wire. It's just there. It's great. No problem. They're upgrade safe. Upgrade to a new PHP version, or upgrade my code, and a string will always be a string. It doesn't, right? If I have a serialized class and I change the class and then try to deserialize it again, I might run into trouble. I don't have that issue with scalars. They're relatively fast, at least compared to a big bunch of objects working together. And they're language independent. So I can take a value, write it in some JSON, and JavaScript can work with it. Try doing that with a PHP age class, right? JavaScript, of course, can't work with PHP classes, and vice versa. And that's true for any language. So scalars are incredibly portable, and that can be very valuable, right? I'm open to change things down the way if I decouple them. So when it comes down to thinking about, do I want to use a scalar value somewhere or a value object, it once again depends for me. So this is basically my takeaway. I really like value objects a lot, this kind of immutable, valid objects, but I prefer scalars at the boundaries of things. So if I'm using a PHP library or I'm writing a PHP library, I don't want to force any clients that use my library to create a lot of classes. Instead, I want them to pass scalars in, and I will create my internal value out of them inside of me. I don't want the others to know about them. Right? So scalars make great boundaries. And that's also true for web API, because I can easily move scalars to the outside world. Message queue payloads, right? That's where the value of scalars really shine, and that's because it's less dependencies. I'd have to worry less about dependencies. There's always an implicit coupling to the format of the data, but that's just the nature of the beast, right? But we're dealing in information and we can't take that away. But at least we can take away a lot of the complexity between class dependencies. All right. So this is relatively short. Immutable variables. In PHP, we don't have them. So done. But we can treat variables as immutable. So what I mean with that is, this is an example of not treating variables as immutable. As soon as we assign a variable, the idea is to not assign it again. So this here is request and $app is both being assigned twice in this example test here. So what's the problem with it? It's not as easy to extract. I can do it manually, but I can't use tools to do it automatically for me because the PHP Storm doesn't know that, this app variable isn't used anymore. It'll try to create weird return structures. So that's one problem. Plus, it's not as easy and simple to reason about it. Since I might have one value already in a class, in a variable from further up somewhere else, and I might not expect that or forget about it. It's very easy to avoid. Simply, every assignment should be done with a new variable name. Simple as that. And that's treating them as immutable. The benefits by far outweigh the additional memory usage, except for very few edge cases. But by default, I always try to treat my variables as immutable now. Now it's very easy to extract. It's much easier to avoid bugs like calling run without sending response on the wrong app instance. Right? The code becomes safer that way, and I find I produce less bugs, easier to reason about. A typical use case also where variables are treated as mutable are loops. So this is the example from earlier, right? Looping over the media gallery array. Here, the image variable is assigned once for each entry in the media gallery. So it's mutable. And also the entries array is mutable. It's an accumulator. It accumulates all the values. So how can we deal with this kind of loop structures and mutability variables? And the answer is, well, it comes down to writing code in a more functional style. So for example, using array map. Within the scope of the closure here, image is never reassigned. And the return value arrays, it's a more declarative style of development, right? We're not even building the array. We don't care how it's done. We just say, okay, do this for every record in the array, media gallery, and that's my return value. So immutable variables increase reasonability. That's always what it comes down to. I might have to think more about it, but at least it's easier to think about it because I only have to deal with this one case instead of all the cases. I find I create less bugs. It's I have the experience of, okay, I've written this method, run the test, and oh, it works, great, right? And otherwise, that didn't happen quite as often. It's much simpler to refactor, and these are my new friends for writing this kind of code. So, yeah, these kind of, it disclosures a lot more, all the functional array map reduce methods, and writing that kind of code in PHP is not pretty. So I try not to take it too far, nesting array maps too far. Other languages have a better collection abstracts that deal more easily and in a more pretty way with it, than PHP. But it's still, without going over the top, it's very useful for me to use this kind of tools. Okay, so I think time's up. I'll skip this last one. That's not the most important thing. Right, so I'm still learning. I've been doing this kind of work now for about 2 years, and so far the results have been quite promising. So my code now looks quite different than it did 2 years ago. And that's true as well for Magento code, or code I try to write more as an extracted library code, not directly inside of Magento, as well as greenfield development or other frameworks. So I would be really curious to hear your thoughts or maybe experiences with it, and or encourage you to just try it out and see where you end with. So thank you. So what do you say? Do we have time for questions? Or 2 questions, okay. If any. Okay.
Yeah, so when you're extracting code out, so you've got a big method or a big class that you're looking at, what do you look for to start identifying what to extract out? Is there any common patterns that you follow for behavior or names that just jump out and you tend to follow, or is it just...
Yeah, that's a good question. So first of all, normally it actually is just about method size. So if I have a method that's 10 lines long, I think it's too long, actually. So some of the example that I first wanted to take was like the category move method, which is like 70 lines, but putting that on a slide doesn't work. Yeah, I just try to make things shorter, and more expressive all the time. I can always move things back in again if it turns out it wasn't a good idea. PHP Storm is a great tool, by the way, to do that for me. They've got great, yeah, it's almost like doing Java. It's really neat. Most of the things it gets right. Okay, cool, thanks.